Hi there folks, welcome to our first review for Quantitative Skills and Reasoning, Exam 1, and today we're going to be covering topics including logic, set theory, and some problem solving. Those will be the main ones, also conversions. Those will be the main ones appearing on your exam. So if you have any questions at any point in time during this live stream, there's a chat box over on some side of your screen. You can always just post a question in there. There will be probably a little bit delay, but once I see it pop up, I'll answer that question as best I can, and that's what I'm here for mainly. So without further ado, let's get started and begin with the first problem. So we're determining the truth values of the following statements. So the first one, the deaths due to natural disasters has decreased over the past 100 years, and the life expectancy of the people on Earth has increased over the past 100 years. So anytime you see something like this, where you have some statement we want to determine its truth value, we need to find if there's any logical connectives. So in fact there is. If you look, the logical connective is and so that means we're broken up into two statements. We have a P statement essentially and a Q statement, and that's what I'll write right here. This is a good way to approach these problems. So the P statement, we can consider that to be this first part, and so I'll put it in quotes right there. The deaths due to natural disasters has decreased over the past 100 years. Okay, and then so we can determine if that statement is true or false. Now you might not know the answer to that right off the top of your head. Actually, a tendency with this question is most people actually get it wrong, and you'd be surprised to know that it has decreased. And so this statement is actually true. Okay. If you want to find where that you can see all that information, actually for both of these problems, you can go to www.gapminder.org as of right now, and that will actually tell you, it talks in depth with a lot of these things and gives you some statistical data to back it up. So very good site there to kind of check out. And don't worry, we'll be referencing that later in the course too when we get to the stats section. So now in terms of the Q, what is that statement? Well, it's the second part, the life expectancy of the people on Earth has increased over the past 100 years. And this is actually also a true statement. Once again, you can go to the same location to see that. Actually, quite surprisingly, you'll see a huge jump even from some of the best nations in terms of life expectancy to some of the, when I say best, I shouldn't say that. I should say in terms of their GDP, some of the higher GDP nations, there's a tendency to have a higher life expectancy. But that's even when that was back in, what would be, 1918 now? It has actually, those top ones, even some of the lower GDP ones now, exceed some of what the top ones were back in 1918. So tremendous progress in terms of life expectancy. So now we have a true and a true statement. So notice the thing we're dealing with essentially is a P and Q. Right, so what I like to refer to often, I'm not saying you have to, if you know these by heart, that's awesome, but is a truth table. So I do P, Q, and then I do P and Q. And hopefully that's showing up in the screen there. So the scenarios for P and Q, you can go true and true, and then you can do true and false. You can do false and true, and then false and false. And the rules to P and Q is if you have P and Q, it is true only when both the P value and the Q value are both true. So this would be true, and then that means the rest are false. Okay, so now if you take a look, which scenario do we have here? Well, notice our P value is true and our Q value is true. So here's our P values being true, and here's our Q values being true. So notice the only one where we have the matching in both parts is this. So that means our value for our truth value for P and Q has to be that T right there. So this truth value is actually true, and that's how we go about getting our answers. Are there any questions on that? Okay, I don't see any questions, so we'll kind of move forward into the next one. So next one, we have an OR statement sitting in between. So technically, if you read the two statements, you have P being your Tim Cook is the CEO of the Gates Foundation. Or, and then our Q statement is what appears after the or, Tim Cook is the CEO of Microsoft. Now, you might say this would be condensed. The reason why it's written this with this sentence structure, we could have said Tim Cook is the CEO of the Gates Foundation or Microsoft, right? If we had said that, you have to recognize that we can't have a fragment for that second statement, and so that's why our second statement has to be Tim Cook is the CEO of Microsoft. So this isn't the only way to word it, but hopefully you can see how this works out and how we have the two statements written out right now. But there's other ways to write this so it sounds a little bit more proper, I guess, would be the way you can word it there. But now Tim Cook is actually the CEO of Apple as of 2018. So this statement about the Gates Foundation is actually false, and so is the statement about Tim Cook being the CEO of Microsoft. And say you didn't know this information, that's what Google's there for. It can help you out and all that jazz. So now, same thing, we can do a truth table if need be. So you have P, Q, and then you have P or Q. So with the P, we can do the same kind of chart. We can do true, true for P and Q, true, false for P and Q, then false, true, and then finally false, false. Okay? So now for P or Q, if one or more of P or Q are true, that means P or Q, the statement P or Q, actually is true. So notice in the first row you have at least one true, in the second row you have at least one true, and in the third row you have at least one true, and in the fourth row you have two falses, so that means this is false. Now our scenario is false and false, and I'll just kind of hop to it here. You have false and false in this last row, so that means our P or Q value has to be false, and that's how we get our truth value. Questions on that part? Okay, without seeing any questions, we'll move forward. So now, getting into the converse, inverse, and contrapositive of the statement, and we want to determine the truth value of each statement. So we'll go through a couple things here. First, you have what's called, when you see this, this is an if-then, or what we also call an implication. So you have if-then, so that means we have a P, which we'll call our hypothesis, and a Q, which we'll call our conclusion. So the hypothesis is Asia is not a continent, and since Asia is one of our 7 continents, we know that this is false. In our second one, Norway is a country, and it most certainly is over in Europe, so this is actually true. Okay. So now we have this, and we can actually figure out the implication itself just by doing, so this is if P then Q, or another way to do this, this is P implies Q. So we can figure out with the truth table what's happening here. I'll actually write it out, if P then Q. You could also use a symbol and things like that. So same song and dance for the possible truth values. Now, when looking at the chart for this thing, we have true and true. If P then Q is true in that case. True and false. So if true then false, that actually is a false statement. Now this is where it gets tricky when you have a vacuous, this is kind of your vacuous situations. If your P value is false, and if P then Q, that makes this true in both cases. So you have only cases false when you go true implies false, essentially. So notice, what do we have? Our P value, to start with us here, we have P is false, and then our Q is true. So notice that means this whole statement, even as absurd as it sounds, the implication itself is true. Now, we'll start with, what do we have? The converse. Now, if you don't recall, the converse goes if Q, then P. Okay, so the converse should look like this. We have Q, we have P, so it should be if Norway is a country, then Asia is not a continent, because if Q, then P. Now this is where it'll get kind of confusing. Notice we have, so up here we had P and Q, we went if P then Q. We want to do if Q then P, essentially. But notice what will happen is you have a true here and a false there. So you have a true implies false, essentially. So true implies false. Notice that's in the second row, and that means that we're going to have a false statement overall. And this is the big mistake that a lot of people make. They think that just because they have one direction, right, so the implication being true, they think the converse would have to be true. It's not the case, and this shows you that it isn't. But there are special cases where they are. And one of those cases that we can look at what it's logically equivalent to. So we have inverse. So the inverse statement looks at if not P, then not Q. Now, here's a little comment that you might have seen before. This is logically equivalent to the converse. So we already know without doing any work, since we have the converse, we know that this has to be false. Okay. So let me erase this real quick for us. And I'll make some room to make not P and not Q. Okay, so not P. So Asia is not a continent. So that would be Asia is not a continent. Well, notice that's a double negative, so that turns basically to a positive. So you have not P would be Asia is a continent. But that means not Q. We need to negate that Norway is a country, so that means Norway is not a country would be our statement here. Okay, so now making the statement, we use the not P, which we have right up here, and the not Q. So it goes if, and then we put down not P, which is Asia is a continent. And then we put down not Q, Norway is a country. And we know this is false because it's logically equivalent to that converse. Okay, so now we have one last one here, a contrapositive. And hopefully you have enough room for you to see it on the screen. So with a contrapositive, that goes, you kind of switch the order here. It goes if not Q, then not P. And then with the contrapositive, I know it seems counterintuitive, but this is logically equivalent to the implication. So the original implication was true, so we know that this has to be true. Now the contrapositive, if not Q, so we'll go if not Q. So Norway is not a country. Then, and then our not P is Asia is a continent. And we know that since this has the same same truth value as the original implication was true, so this thing's true as well. Wowzers, right? A lot of work, but hopefully if you have any questions, just let me know. But that's what we're trying to do, is just break these things on down, make sure you can handle these, and see what's happening with each scenario. So in terms of logic, those are the main things that we're getting at. Now we're going to move into some set theory. So consider the set S equals ABC 1, 2, 3, and we want to give 3 examples of subsets of S. So let's create our first subset. So what does it mean to be a subset? It means you have all the elements in this set appear in the set S as well. So I can just pick randomly, and they don't have to be in the same order. We can do 2, A, and 3. That would be an example of a subset, because 2, A, and 3 are all elements in that set. If we did Y, for example, notice we could do, say, 4, oh, not 4, I'm sorry. Sorry about that, getting ahead of myself. Let's do B, C, 1, 2, 3. Notice all of those elements in Y also appear in the set S, so this is also a subset of S. If we try Z equals, now let's pick something kind of at random, let's do B and 3. That's also a subset. Now some crazy cases, I know it asks for only 3 examples, but is the empty set. So, and this is denoted by there, because notice this is kind of your vacuous statement. There's no elements to check, so it's vacuously a subset. You could also have said the set S itself, because it didn't say the word proper subset, so S is a subset of S. So those are some other examples that you could have tossed in there. The list goes on, but in fact you could find 2 to the 6th different subsets overall. So there's quite a few examples you can go through there. Alright, so 64. Right? Give 3 examples of sets that are not subsets of S, nor are the sets disjoint with S. So that's actually important. They're not disjoint. So if they're not disjoint, that means they have to share at least an element. So let's try the set P. And I'm just making up letters for calling the set. I could call it whatever I want. But okay, so now on this one, we can toss in something, so maybe A in there. But now let's do 4, 7, 8. Notice 4, 7, and 8 aren't in there, aren't in the set S. So that means these 2 sets are, you don't have one being the subset of the other. Okay. In another case, we could do Q. And I'll give you something a little bit more fancy than this. So let's say we got to toss in elements that are in there. So we'll toss in B and 4 and, or not B and 4 and 3 to start off. As soon as we see that 4, we know immediately that it's not going to be a subset. But just to, actually let's try and make it a little trickier. Let's go B, 2, and 3. So far we're a subset. And now what I'll do in this case is something like that. Now you might think this is a subset, but let me explain. Why not? Enclosed inside of these curly brackets, right? There's your curly brackets on the end. What are the elements listed inside of here? Well, the elements are B, 2, 3, and this squiggly line, right? Because it appears after the comma and there's nothing to close it off. So that is an element as written. Okay. But notice this is not an S. It doesn't appear inside of these 2 curly brackets. In a similar manner, if you want me to raise the stakes a little bit more, I'll give you a much trickier example. Don't worry about this. The easier ones is what you're dealing with for the most part. But so notice, let's do this. We'll do R equal to, we'll toss in an element that's inside there, so we'll say 1. Okay. But now I'll do something like 1, 2, 3, put a comma, and let's do another AB. Now you might think this is a subset. It is not. The elements are. There's only 3 of them. 1. Here's where it gets tricky. Now notice you see this start, but there's no comma after. So that means it's grouped with this other bracket. So that means there's a set inside of this set, right? And it closes off here. So our second element is the set containing the elements 1, 2, 3, right? And then on the third case, notice here's a bracket, but there's no comma after it, so it means there's nothing in terms of it being an element. It's closed off with that bracket, so everything inside of there is included. So you have a set containing AB. So you only have 3 elements, but this, I know you see A and B inside of here, but you don't see, so there's an A, there's a B, but you do not see curly brackets surrounding that AB. So this and the 1, 2, 3 are not elements of S. Okay, so that's the tricky part. You think they are, but since there's a set that's grouped them together, so see that those endpoints? Those endpoints right there says they would have to be grouped inside of the curly brackets on the outside, right? They don't appear in there. So that's one of the trickier cases. If you want an easier case, I can give you something real easy. Just take, let's say, C, and we'll do 19, right? That would be, 19 is not an element, so it's not a subset. But I just wanted to give you something how these can be tricky sometimes as well, and let you see and play with some of the different subsets. Okay. So now, consider the sets where we have x equal to 1, 2, 3, ABC, and then y equal to 2, 4, 6, BDF, with the universal set being 1, 2, 3, 4, 5, 6, 7, 8, or 5, 6, sorry, getting in the 7, 8 there, A, B, C, D, E, F, okay? Been counting too much with my younger ones at home. So, x union y, what are we doing? Well, we're just writing down the elements from both x and y. Okay, well, that's simple. So we can start 1, 2, 3, and then A, B, C. That's all of x's elements. And now I can write down all the elements of y, but notice, if I write 2, it already appears right there. Okay, so I don't need to write 2, because it's already taken care of inside the set. So all we need to do is write down 4, 6, that's a new one. B is already in here, so notice B appears right there. So, and then D is not in here and F is not in here, so we'll include those. And that's the whole union. Okay, so union is the whole, the two sets is combined together and then getting rid of the repeats. Versus the intersection, what does that equal? Well, the intersection is what they have in common. So if you notice, 2 is in both sets. Okay, and then also B is in both sets. There's no other elements that appear in both sets, so our intersection is just the elements 2 and B. So now let's check out, what does this mean? Well, you see those absolute value. You might see an n as well. This is also equal to n of x. Just a couple different notations that you might see. So those stand for the cardinality of the set x, or meaning the number of elements inside of x. Okay, so when we take a look at this, what actually happens? Well, let's count the number of elements in the set x. You have 1, 2, 3, then 4, 5, and 6. So that means the cardinality of the set x is 6. In a similar manner, we can count the elements in y. I'm not saying this will always happen where we have all the elements. But so the number of elements in y, you count them 1, 2, 3, 4, 5, 6 once again. Okay, that's the cardinality of y is 6. Moving forward, we can do the union. And I want to emphasize this one real quick. So on the union, to get our heads around what's going on here, we could count the elements down below. So you get 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And so we could get 10, which is, that seemed pretty easy. But there's another way we could approach this. Let's say we had a very large set, and this will actually come in handy later. Notice I'm writing the cardinality of x intersect y equals 2. But here's what happens with the union. If we take the cardinality of x plus the cardinality of y, notice that we've counted essentially the 6 in the set x and the 6 in the set y, but we've double counted the numbers 2 and the number 2 and the letter b. Right? They've been counted twice by adding those. So what we need to do is subtract off the intersection. I'm not saying you have to use this method in this case, but notice if we get this, we get 6 plus 6 minus 2 equals 10. So it gives you two different approaches for the same answer, right? And sometimes it might be easier to do that rather than find out and count out every element in the union, right? It's easier to go 6 plus 6 minus 2 real quick. So rather than trying to count those numbers, especially if the list was even longer for the union. Okay. So now with this x bar, what does that mean? Well, that is the elements that are not in x. So this goes the cardinality of the set U minus the cardinality of the set x. Right? If you wanted to figure out x bar, here's how you have to do. Well, I'll actually count it this way, and then we'll show you how you can figure out what x bar is. We'll do that after the fact. But notice if we count the elements in U, we go 1, 2, 3. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is 12 minus 6, which equals 6. Now, in case you wanted to get x bar, I'll write it up top here. So notice 1 is in x, so that means it can't be in the complement. So 1's not in there. Same thing with 2, same thing with 3. 4, 5, 6 is not in there. So not in the set x, so we wouldn't cross those off. But A, B, C, R. So we'll cross those off in this set. So what is left is what our complement is. Those are the elements in U that are not in X. That's what complement means. This will come in handy very much later on in the semester when we get to what's called probability rules. Right? There'll be a probability where we're looking for an event to occur, where the probability of the event E is what we have. But we want to find the probability of not E. You just go 1 minus the probability of the event E. Alright, so that had overlap. And let's see what happens in terms of pictures in overlap. So some people like a Venn diagram. Right? And that's what we'll do here. Let's say we have our three sets x, y, and z. Now when people go to fill this in, they just start from, oh, okay, the number of elements in x is 17, so I'll put 17 out here. It doesn't quite work that way, and let me explain why. Notice this centerpiece right here, right in here that I just highlighted, that is the intersection of all three sets. Okay, so that has two elements. So notice though, those two elements are still in x, those two elements are still in y, and those two elements are still in z. So we have to be careful. Now let's check out y intersects z. Where would that be? Well, that occurs right over here, right, in that little area. So with y intersects z equaling 3, how can we figure out? We've already accounted for 2. Let's call this smiley face for right now. Notice what happens. Our smiley face plus 2 equals 3. So if we're to solve for how many appear right there, we take our smiley face equals 3 minus 2. Okay, so our smiley face equals, and we got that from subtracting 2 from both sides. So our smiley face equals 1. So that allows us to put in 1 in that position. Okay, so notice we're kind of working backwards in terms of we do this stuff with the most overlap, then we work our way on up. So now let's use blue here. We have x intersect y equals 9. So that occurs up here. So now let's call this star. So we have star plus our 2, right, because that's in that x intersect y as well. That should equal 9. So notice our star equals 9 minus 2. So our star equals 7. So in this case, we get star equals 7 right there. In a similar manner, we have x intersects z equals 6. So let's put triangle. So we know triangle plus our 2 equals 6. If we're to solve for the triangle right there, triangle equals 6 minus 2. So that equals 4. And so if we put that in there, we get 4. Now here's where things get fun. We have the cardinality of z equals 13. Okay. So notice we have z, and we have this 4, 2, and 1 sitting inside the circle for z, right? And so let's call this square maybe. So we have square plus 4 plus 2 plus 1 equals that 13 that we've mentioned up above. So notice that's 6 and 7. So we have square plus 7 equals 13. So square equals, you subtract 7 from both sides, 13 minus 7. So that equals 6. So notice we can put a 6 right here. Okay, so now what's our next one? Y equals 20. So let's put a tornado looking thing in for y. So if we take tornado plus 7 plus 2 plus 1, because the 2 and the 1 sit inside of that y circle, that whole thing should equal 20. Now notice that tornado plus 10 equals 20. So that means tornado equals 20 minus 10. And so our tornado happens to equal 10. Alright, so we're almost there. And now we have x equals 17, the cardinality of x equals 17. So if you look at this component, let's give this a name, alpha. Alpha, notice plus 7 plus 4 plus 2. And that should equal 17. So notice that's alpha plus 13 equals 17. So that means alpha equals 17 minus 13, and alpha equals 4. So we can erase that and put in a 4 right there. So notice, if we could reword this now. We have the number of elements appearing in x only is 4. The number of elements appearing in x and y is 7. The number of elements in x, y, and z is 2. The number of elements in x and z is 4. The number of elements in y only would be 10. So notice there's different ways I word this, right? So now I have two different approaches, and I'll show you both. We could have done this without filling in the Venn diagram, and I'll show you how to do that as well in a second. What was kind of the main idea that was happening there. But so now all we need to do to figure out this union, remember that's all the elements included, we just need to add all the numbers across. So I'll go 4 plus, I'll do the ones with only, so x only, y only, and z only. X, so 4 plus 10 plus 6 plus, then we do the intersection of 2 at a time. We'll do, so just x and y would be 7, just x and z would be 4, just y and z would be 1. And then finally we add in that last piece there, so the intersection of all three, like where all three sets are included, is 2. Now notice I was using that word only, and you got to be careful there, and I'll show you why, what happens in the other case. So notice, what does that make? That makes 27, 31, 32, 34, I believe. And that seems like a reasonable final answer. Well, another approach, kind of building on what we did on the previous page, is we can sum up the three separate cardinalities. But notice, let's look at like x and y, for example. If now I'm going back up to the stuff up here for these numbers, right? If I consider something that's in x and y, right, Notice I've counted it once for x and I've counted it a second time for y. So we need to subtract off that intersection. So we'll subtract off the intersection of x and y. Same thing, anything that's in x and z both, we've counted that twice, so we got to subtract that off. And then the same thing happens for y and z. Oops, that was an intersection. Now think about this. If you're in the intersection of all three sets, notice you've been counted 3 times for the cardinality x plus cardinality y plus cardinality z, but then you've been subtracted 3 times by the cardinality of x intersect y, and the cardinality of x intersect z, and the cardinality of y intersect z. So what we'll do is we'll add that number back in. And let's see if we have a different way of getting the same answer. So notice if we take this, we get 17 plus 20 plus 13. X intersect y is 9. Sorry, I wrote it in a slightly different order. X intersect z is 6 from up above. And notice I'm not having to do any work with the Venn diagram in this case. And y intersect z is 3. And then we have to add in x intersect y intersect z, which is 2. So notice if you add this, 17 plus 20 is 37, plus another 13 is going to be 50. Minus, here, 9 minus 6 minus 3. So negative 9, negative 6, negative 3. So this will be 50 minus 18, and then plus 2, right? So 50 minus 18 is 32, plus another 2 is 34. And notice I finished with that same answer that we had up above. So just trying to show you a couple different routes to get there and what happens. Now, the other thing I was mentioning, I kept on using that word only. I'll actually skip forward here in just a second. And I want to try and illustrate that because this one, a survey revealed the following results about the news sources that a sample of 130 people use. Draw a 3-circle Venn diagram that summarizes the results. Okay, so we have some overlap. You can see they have all 3 sources and all that stuff. In this Venn diagram, though, there's really not much work to be done. So first off, we have TV, radio is one possibility. You have internet, and then you have newspapers. Okay. So let's look. This first thing says TV, radio only. That's a key word there. Only. That means it's only appearing in this part of the circle. It doesn't take on the whole circle. So you can just put that 20 in there. If it said TV, radio, and there's no word only, that's when we have to do the subtraction. Okay, that key word is only there. And that gives us internet only. That's going to be pretty easy. 29. Newspapers only is going to be 15. So we can just, with the words only appearing, and see they do in each case, we can find out where to place them and not have to worry about subtracting. Versus the other case, it didn't give us the word only along the way. So now this one, TV, radio, and internet only, right? So you have 12 appearing right here. So TV, radio, and internet would be 12. We'll put that in. TV, radio, and newspapers, 18. So that goes TV, radio, and newspapers. Where do those 2 circles overlap? And that goes right there, 18. And then internet and newspapers only, that's 22. So internet and newspapers is 22. And then finally all 3 sources, well, not finally, I should say. That's 8. And then none. Where the heck do we put the none, the 6? Well, that goes outside of all 3 circles. Okay. So now, when we do this, how many people use TV, radio, or internet? So this is, I'll highlight the circles from the standpoint of what we're looking at. So notice, these are the circles where we're going to be adding up all the numbers, right? What I just enclosed here. So right around here, including that, all these, that's what we're looking at. So here's how we do it. We just add them all up. So 20 plus 12 plus 29 plus 18 plus 8 plus 22. Bear with me, I'm not going to use a calculator, so if I make a mistake, just double check it. So 20 plus 12 is 32, 41, 61, 79, 87, and then that makes 109. Oh, I'm sorry. Not just 109. 109 people. That's better. Okay. questions on that one? All right. So let's go back. As I said, we skipped over a problem real quick. So we will try and handle this one. We want to determine the number of cubic feet in 6 cubic yards. Okay? So what does that mean? Well, 6 cubic yards is 6 yards times yards times yards. Right? That's what cubic yards means. So if I do yards cubed, right, that's what cubic yards are. That's yards times yards times yards. So we got to get rid of yards times yards times yards. So the only way we can do that is put a yard down below. And we have to do it 3 times. So now we need to figure out a conversion between yards and then the unit we want is feet. If possible, maybe we can have something that goes feet, feet, and feet. Well, one thing we know is that 1 yard equals 3 feet. Okay, so that means if 1 yard equals 3 feet, that means we can put a 1 yard there, the 3 feet up there, put a 1 yard here and put a 3 feet there, and then we put a 1 yard here and we put a 3 feet there. Now notice what happens. Our yard right there will cancel off with that yard. This yard would cancel off with this yard, and then this last yard would cancel off with the last yard. So we're left with 6 times 3 times 3 times 3, and then we have feet times feet times feet. Right? And so that makes, just to make your life a little easier, 6 times 27. And 6 times 27, that's what? 120 plus 42, 162. So 162 cubic feet. That's all there is to it. Now, working in another problem, how do we determine the number of square meters in 1,500 square centimeters? So notice we have 1,500 centimeters times centimeters, right? So what that tells us is if we have that up top, we multiply, we're going to have a fraction, and we're going to want centimeters down below because that'll cancel off, right? So what we want to convert to is meters. So we'll put meters up above. So we need to think of a conversion that has meters from centimeters. So if you think about it, 1 meter equals 100 centimeters. So that means we'll put 1 meter up top and 100 centimeters down below. Put 1 meter up top, 100 centimeters down below again. Right? And so if you take a look at that, what does this mean? Well, first off, let's look. We have centimeters cancel off with that centimeters, and this centimeters cancels off with that centimeters. So now we have 1,500. Now we're going to divide by 100 times 100 down below. Okay, and so you can make your life a little bit easier. So this 100 will cross off with the 2 zeros there for the 50. So we're left with 50. No, let me cross it off this way. So we're left with 15 over 100, and then I should put meters times meters. Sorry about that. So then what do we have? Well, if you look, if we go 15 over 100 meters squared, that works. But another way for us to write this, if you think of it as a decimal, you move 2 decimal places to the left, it's going to be 0.15 square meters, and that's our final answer. So I'll let you see when sometimes you have that number being divided by some number bigger than 1. Sometimes it's multiplied. I wanted you to see both cases. It's all dependent upon what our conversion is. Okay. So hopefully that makes sense on the first type of conversion. Don't worry, we'll do a few more. So our next one, say we have a new sidewalk will be made 4 feet wide, 200 feet long, and filled to a depth of 6 inches, which is a half a foot with concrete. How many cubic yards of concrete are needed? So if you take a look at this, it's a beautiful drawing of a sidewalk, right? And we want that sidewalk to be 4 feet wide, 200 feet long, and then the depth of this thing, so let me put it right there, is, now notice it says 6 inches. You could put 6, but you need to keep the same units, so this is 1/2 of a foot. It's a rectangular solid, right? So how many cubic yards of concrete are needed? We need to first figure out what is the volume of this thing. So the volume equals, this is length times width times height. You need 3 dimensions to deal with it, right? So the length of this thing is 200 feet times the width, which is 4 feet, times the height, which is a half a foot. Okay, if you multiply all those together, so you can go 200 times 4 times 1/2, right? And then this will be feet times feet times feet. So this means our volume equals 400 cubic feet. But notice, so that's our volume, and that's how much concrete we're going to need. We want to know, though, how many cubic yards. So cubic yards, notice we have 400, and I'll write it back as feet times feet times feet. That means in this case, we're going to want the feet down below. Okay. Well, if that's the case, we want yards up above, and we can recognize that 1 yard equals 3 feet once again. So 1 yard equals 3 feet. And so that means, oh, and I should label, this is the amount of concrete. So now, if you do this, you'll cross off the feet, and you're left with yards. So it goes 400 divided by 3 times 3 times 3. Now notice 400 is not divisible by 3 cubed, essentially. And this is yards times yards times yards. So we will probably need a calculator for this one. If you type in 400 divided by 27, if you can do it in your head, that's great, but if not, no big deal. So this would be something like, if we're rounding 2 decimal places, we'll go 14.81 cubic yards. But now, so you could need 14.81 cubic yards. Now, if selling, keep this in mind, from a store, so that's how much is needed, and it didn't specify in the problem. Just said how many cubic yards of concrete are needed. That's our answer, right? That's how many cubic yards of concrete you need. But if selling from a store, what happens? Well, you couldn't just say, oh, 14.81 cubic yards if they're selling by the cubic yard. Then what you need would be to round up, right? So we know if we're going to buy it from a store, we have to have those 15 cubic yards in order to handle it. 14 would not be enough, right? We wouldn't be able to fill all that concrete. Okay, so hopefully that makes sense in terms of how we can actually look at this. So this is a side note, I should say, in terms of that. That way you can kind of see the difference. All right. So moving forward, we got a different problem here. We have gas mileage actually varies slightly with the driving speed of a car. Suppose your car averages 38 miles per gallon. So first off, if your average speed is 55 miles per hour. So I'll write this at 55 miles per hour, right up here. Then what happens? That means 38 miles per gallon. That means every 38 miles, that should be equal to 1 gallon. Okay? And it averages 32 miles per gallon on the highway if your average speed is 70 miles per hour. So at 70 miles per hour, let me just put mph, sorry for that. What do we have? We have 32 miles equals 1 gallon. So just kind of breaking that down. And actually I could break down 55 miles per hour. That's 55 miles equals 1 hour, essentially. So first off, oh, the first question is dealing with driving time. So what is the driving time for a 2,000 mile trip if you drive at an average speed of 55 miles per hour? So at 55 miles per hour. So there's 2 other pieces that we can toss in here, and I'll put them up here. So let me put at 55 miles per hour. What does that mean? It means 55 miles equals 1 hour. And then at 70 miles per hour, it means 70 miles equals 1 hour. Right? So at 55 miles per hour, let's see what we start with. We have a 2,000 mile trip. So that's what we're starting with. 2,000 miles. And we want to turn in that into time. So the thing that gives us time is right up what we just wrote. 55 miles per hour means 55 miles equals 1 hour. So we'll put the 55 miles down below. That'll cross off with the miles up above, and that should equal 1 hour, so we'll put the 1 hour up above. So notice our miles cancel, and so what we're left with is 2,000 divided by 55 hours. Right? And you can figure out that as our answer, so you just go ahead and plug and chug. And this is going to be approximately 36.36 hours. Now, if we did at 70 miles per hour, what's going to happen? Well, the only change here is 2,000 miles times. In that case, we'll go to our 70 miles an hour scenario. That means 1 hour equals 70 miles. So our miles will cancel, right? Which is good. And you're left with 2,000 divided by 70 hours. So if you go ahead and figure out 2,000 divided by 70, you'll see that you cut down your time quite a bit. You get 28.57 hours. So if you drive a little faster, obviously you're going to get there a little faster. So rather than 36 hours and some change, you'll get there in 28 hours and some change. Okay? And some change meaning a number of minutes, by the way. So, questions on that? Okay, I don't see any questions, so let's keep on moving forward. Assume a gasoline price of $3.90 per gallon. What does that mean right there? Well, that tells you 3.90, $3.90 equals 1 gallon. What does the gasoline cost for a 2,000 mile trip if your average speed of 55 miles per hour? So let's talk about that. At 55 miles per hour, what happens? Well, you have a 2,000 mile trip, and we want to turn this into dollars, right? What does the gasoline cost? But in order to turn it to dollars, notice we need gallons somewhere along the way. And the only place we can use gallons is the fact, and I'll just star that right now. At 55 miles an hour, you have 38 miles equals 1 gallon. And so we'll use that. So we have 2,000 miles times. We want to cross off miles and we want to convert it to gallons because that'll give us a nicer conversion. So notice the conversion rate, we have 38 miles equals 1 gallon. Right? So I'll change this to blue now. So notice the miles will cancel and we're left with just gallons. So now what we have to do is we need to cancel off the gallons. Well, that's $3.90 equals 1 gallon, so we can type that in. So notice we get gallons would cancel, and so this is 2,000 times 3.9. Instead of writing 3.90, you can just put 3.9 and 38, and then this will be dollars, right? US dollars, in fact. So if you actually go through this calculation, you'll see, and we'll round it to the nearest cent. So this is $205.26. Now at 70 miles an hour, the process is pretty much identical. The only difference is you have 32 miles per gallon, which I just starred up there. So you get not as good gas mileage, which makes sense. You have 2,000 miles times, now there's 32 miles per 1 gallon. times, you have 1 gallon is equal to $3.90. So notice this is 2,000 times 3.9 divided by 32. And by the way, your miles will cancel, your gallons will cancel. Right? And this will be in dollars. So what does this actually equal? Well, if you go 2,000 times 3.9 and you divide by 32, notice your cost is going to be a bit more. And this will be something you have to weigh. Is that extra time saved worth the extra cost? So you get 8 more hours to fool around once you get there, right? Because it cut off 8 hours off your trip, but it costs you approximately an extra $40, right? These are the types of things I want you to be able to contrast and compare and see what's worth it to you, right? Critical thinking at its finest. Speaking of critical thinking, I'm just tossing one problem in here because it was one that a lot of people had asked about. So the following rules are among many provisions of a particular credit card agreement. For the regular plan, the minimum payment due is the greater of $10 or 15% of the new balance shown on your statement, rounded to the nearest dollar, plus any unpaid late fees and return check fees, and any amounts shown as past due on your statement. I'll stop right there. Notice it's a whole bunch of ands. So you're adding each of those on in every single scenario. Okay. So now, if you make purchase under a regular plan, no finance charges will be imposed in any billing period in which there's no previous balance or payments received and credits issued by the payment due date, which is 25 days after the statement closing date, shown on your last statement, equal or exceed the previous balance. If the new balance is not satisfied in full by the payment due date shown on your last statement, there will be a finance charge on each purchase from that date of purchase. Okay. So there's no more extra ads right there as written. But so now we have a new balance in your account is $8. So let me write that down, just doing some critical thinking. New balance, and not the sneakers, that's equal to $8. And then we have $35 in unpaid late fees. So unpaid late fees equals $35, right? So first off, for the regular plan, the minimum payment due is the greater of $10 or 5% of the new balance shown on your statement. Okay, greater of $10 or 5% of what's our new balance? Well, it's $8. Okay. Well, it doesn't take much to check. If you do 5% of $8, notice you're already with the $8, you're underneath $10. But so even if you want to check it, this part equals 40 cents, just to verify. But notice you want the greater, so our greater is $10, but that's not it. Plus any unpaid late fees and return check fees. Notice there's no return check fees, and any amount shown as past due on your statement. So we have unpaid late fees here, and so let's write minimum payment. So we start with the greater of, which is the $10, plus unpaid late fees. We do have that, so that needs to go in. And then we don't have return check fees. We don't have any amount shown as past due on your statement. So our minimum balance in this case is $45. Okay. Hopefully you can see how we're doing some critical thinking, just reading on through and checking stuff along the way. Right? Take your time, go ahead, check it, make sure all the wording's right, and things like that. And if it takes you more time, that's fine, right? There's no problem with that. So now here's something we all face, and I'll finish with this. When going to the grocery store, Simon comes across two options for purchasing strawberries. Simon can buy a 6-ounce package for $2 or a 1-pound package for $5. And which option is the better buy, assuming all strawberries will be used in either case, so there's no leftovers or anything like that. So the way you want to compare these is the same price scale. So we can either convert to pounds or convert to ounces. I say probably the easier version will be price per ounce. Usually going smaller is easier. So we'll do a price per ounce comparison. So the 6-ounce package for $2. So what does that equal? Well, that becomes $2 divided by 6 ounces, and so that's 1/3, right? Or approximately 0.33 per ounce. All right. In the other case, we have a 1-pound package for $5. Right? But notice here we got a little bit more conversion to do. We have to convert pounds to ounces, right? So how many pounds are in an ounce? I'll give you all a second to see if you can figure that out. And so hopefully you all see it. And so your pounds would be 16 ounces. And so that makes, in our case, we have $5 divided by 16 ounces. And so what should all that equal? Well, when you take that and divide it on out, you get approximately 31 cents per ounce. I know I wrote that a little different here. Actually, I'll make it more consistent with what you saw a second ago. 31 cents per ounce. Now, it doesn't always mean the bigger box there will always be a better buy. Actually, I've seen that trick quite a few times where it's not. So the better buy is the 1-pound package for $5. Okay. Hopefully that makes sense. That way you're comparing the same sort of units. That's the big trick to that problem. Okay. If you have any other questions, there's always the discussion post. You can post in the YouTube live questions or any discussion board that you feel like, and I'll try and resolve it there. But hopefully this helps with preparing for your exams. I wish you all the best of luck coming up. So have a good one.